This is lecture 4 for week 12 of CS 1030. And in this lecture segment, we're going to return to something we've already talked about, that is to say, writing machine code programs, and we're going to talk about it in a little more detail. And the idea is we've already seen enough now for how the simple computer works, how it implements machine language. Now we're going to look at the other side, using machine language to accomplish a task. So the essence of programming always, as I've sort of said many times, and this is just important, so I keep repeating it, is this idea of breaking a larger problem into smaller pieces and then taking those smaller pieces and mapping those onto things the computer can actually do. So of course, that's what we're going to be doing here. So what we want to do is, at a high level, is break our problem down, then take the instructions that we've got once we've broken our problem down into simple enough pieces that they correspond to instructions, write those out kind of in our sort of machine language pseudocode, then translate the pseudocode into binary. And we're not going to make you memorize that. When we ask you to do this, we'll always give you the encoding. Translate into binary, lift it up into hex, put each of the bytes of the instructions for your program into RAM, also add into RAM any data that your program needs, and then you can run the simple computer. So let's go through an example. So the problem here is not a super hard one. We're just going to add 1 plus 2. So we're going to need a program and we're going to need data. So the data for this program is 1 and 2, and then there also is going to be a place where the result goes. So there's going to be 3 memory locations used for data, and then there's going to be some memory locations used for the program. So there's sort of a tricky thing here, which is where do you put the data so that it's not going to overlap with the program? And what we typically do is put the program starting at address 0, and then the data in higher memory addresses. And so if we don't think our program is going to use that many instructions, we can just sort of guess that memory locations 10 and higher aren't going to be used by our program, and we can start putting data there. So we're going to put our input values, 1 and 2, in memory locations 10 and 11. And in memory address 12 is the byte that we're going to use to store the result. Okay, so now that we know where our data goes, we can write our program. So it's going to take 5 instructions to make this work. And here's how we're going to do it. We're going to first load whatever's in memory address 10, that is to say the first thing we're adding, into register 0. Then we're going to load whatever's in memory address 11, that is going to contain 2, our other number, into register 1. We're going to use the ALU to add register 0 and register 1 and put the result into register 0. Then we're going to take register 0, store it into memory location 12. That's where we've decided to store our result. And then we're going to halt the simple computer. Okay, so what have we done so far? We figured out where the data goes. We figured out the sort of pseudocode for the instructions we need, but we haven't figured out the actual binary encoding for the instructions. So let's do that next. So what we do is we use the instruction encoding information. And again, you don't have to, we're not trying to get you to memorize this. We'll provide this for you whenever you need it, to come up with the actual binary instructions for the computer. And this is basically what I showed you in a previous lecture segment. So if we want to load memory address 10 into register 0, remember that the top 3 bits of the instruction byte are going to contain, these 3 values, 0 and 0, which says we're loading from memory into register 0. And the low 5 bits of the instruction byte are going to contain a memory address, and here it's 10. So 0, 1, 0, 1, 0 is 10. Okay, so then we want to load the other value into register 1. So now we're going to use a different instruction, 0, 1, 1. That's the instruction that loads from memory into register 1. And the address we're going to load from is address 11, and that in hex is 1011. So these are remember the low 5 bits of the address of the instruction byte when we're accessing memory contain the memory address. Okay, so the next instruction is an ALU operation, and here we again use the encoding from the information in the previous lecture segment to come up with the bits. And we do the same thing for storing from register 0 into memory address 12. So here you can see that the low 5 bits, 0, 1, 1, 0, 0, that comes out to be 12. And then these 3 bits are what tell us to store from register 0 into memory. And then we halt the instruction. And again, the halt instruction was contained in a previous lecture segment. Okay, so now we have the binary digits that make up the instructions, but that's not actually what we load into the simple computer. The simple computer lets us program in hex, so we do the hex conversion. So this gives us these instructions. And now that we have these, we can actually start poking these into the RAM for the computer so we can make it go. So we're going to call up Logisim, and we're going to load the bytes for our instructions. So here you can see we have 1, 2, 3, 4, 5 instructions, ending with A1, which is the halt instruction. You should always sort of make sure that that's the case. Load it into the low part of RAM, because remember the simple computer wants to start executing at address 0. And then at 10 and 11, at addresses 10 and 11, we have the input data, 1 and 2, and we can go ahead and execute the simple computer. And what needs to happen at the end is when the simple computer hits the halt and stops executing, there needs to be the value 3 stored here. If our machine language program worked correctly, that would be the case. If there was some sort of a bug in it, for example, we made an error in binary to hex translation, then it's not going to happen. That value won't be there, and we're going to have to go debug our program. And the way to debug the program is best done by watching the simple computer execute, figure out if each individual step is doing the right thing. And if the program as a whole goes wrong, it has to be because some individual step went wrong. And if you're watching it execute, you'll see which step went wrong. And that's how you debug it. That's how you know where to fix your program, because you'll see where it went wrong. If you just look at the end result, all you'll see is it didn't do what you wanted. You're not going to know how to debug it. And so you should not just sort of let it go. What you want to do is try to understand each of the steps as it goes. Okay, but I've skipped ahead a little bit. So what we would need to do is figure out how to execute the program once we have the RAM contents loaded properly. And so what you could do is you can either poke those values in by hand, or you can load the RAM contents from a file. So you can both load and save these RAM contents to files using Logisim. Then you reset the simulation. And now you're going to set the fetch and execute and clock. You're going to toggle these lines in such a way that the computer executes. So if you want to do the fetch and decode part of the fetch, decode, execute cycle, you set fetch to 0 and clock to 1. Then to do the execute part, you set fetch to 1 and clock to 0. And you just go back and forth between these things. And you try not to mess up and get these things out of sequence, because then the things might not work right. So that's how you sort of from start to finish take some sort of a high-level problem, like adding 2 numbers, turn it into machine code, get it into the simple computer, and execute it and make it work.